Okay, so hello everyone. Thanks you for coming to the seminar today. Let's start by acknowledging the country that we are gathering in an unceded land that has as traditional pronouns the Gadigal people of the Eora Nation. Today we have the pleasure of hosting Professor Gi-Hyoug. He is from the Ulsan National Institute of Science and Technology, where he leads cheat sheet, the Laboratory of Sustainable Urban Planning and Design. He received first a master's degree at the University of Illinois in Urbana-Champaign and a PhD from the University of North Carolina at Chapel Hill. He's now doing a sabbatical year here in Sydney at UNSW. And today he's going to talk us about what he has been researching about the application of virtual reality for pedestrian safety. So thank you very much for coming today.
Thank you. No, thank you for inviting me. And yeah, I'm very happy to have talk with you guys. And then thank you for inviting me for this seminar. As Dr. Appelbaum explained, my background is urban planning, and one of the persistence research topic is the walkable environments. And also, the walkable means safe environments for the pedestrians. So, I'm investigating the pedestrian safety and pedestrian physical activity and walkable environment. That is my kind of common research topic. And for last several years, I more actively adopted this virtual reality, immersive virtual reality methodology. And today I wanted to share some of my experience, how we can apply this technique to investigate pedestrian safety. Kind of big picture, when explain the behavior of the pedestrian, we heavily rely on rational decision-making model, right? So people always try to maximize their utility. And for instance, jaywalking, of course, this is quite risky behavior, but from the perspective of rational decision making, pedestrian think about by sacrificing their risk. If you can reach their destination much faster, they willingly to make jaywalking. So this rational decision-making model explain a lot, like mode choice and their specific behavior on the road. But I think in the reality, the actual behavior of the pedestrian is much more complicated than this one. And I think one of the main reasons why this actual behavior is much more complicated, hard to explain, is the interactions between the travel agent. For instance, I explained the case of jaywalking. So jaywalking might be quite a rational decision to maximize the utility of the pedestrian. But if you think jaywalking,
Yes.
So without signal, red light.
That's not very well.
Is it?
And crossing against a signal, violating the signal. But jaywalking could be crossing in the middle of the street when there's no signal.
Okay. So anyway.
So I mean, if that's what you mean by it, that's okay. You just need to
Okay. So here I use the term against the signal, So in the red lights, walk the cross the road. So in that kind of situation, of course, that kind of decision making might be rational for the perspective of pedestrian, but it is not quite ideal for the drivers, right? So in a the load situation, drivers and pedestrian kind of compare to each other. So in that kind of interactions, that kind of decision making is much more complicated to explain. So in a VR, in my kind of VR study, what I was mainly focused on was the interaction between travel agents, how these interactions can be observed and investigate, how to understand their psychological aspect and behavior. These are kind of common umbrella of my VR study. So today I want to share the series of the VR study I conducted for the last several years. The first one is how does nonverbal communication between pedestrian and drivers affect the yielding behavior of drivers and risk perception of each travel agent. And the second one is this is a kind of new transportation mode, e-scooter. Right? So if the pedestrian, bicycle, and e-scooters are mixed in one, in a sidewalk condition, how they perceive each other and how they react against the threat to other travel mode. And the third one is it's a collective crossing. We call it collective crossing. So when you, cross the road, in most cases as an individual decision making, but sometimes the presence of peers can affect decision making of mine. So how this again the interactions in between peer and me can affect the decision of the crossing. These are the studies I want to introduce today. So when you think about this kind of very simple terrain load condition, and assume that you try to cross the road and you see that the vehicle is approaching from there. So then how do you behave when you try to cross the road? It's a kind of competing situation, right? So you can just wait, right? You can just wait until the car passes, and then you can safely cross the road. Or if you're in a hurry, you try to give some signs, right? For instance, in Korea, elementary students guided to raise their hand before cross. This is quite a strong sign of their intention to cross. But as you grow up, you do not raise your hand, right? So there is some other types of nonverbal communication to express your intentions of the cross. So how pedestrian express their intentions of the cross and how it affect actual yielding behavior was the main subject of the study. So the ambiguity of priority is always exists, in particular in unsignalized crosswalk. So what we interested in was that there is several forms of nonverbal communications. Now, perhaps the easiest one is just gaze the approaching car, right? So try to make eye contact with drivers, and this one could be a bit weak behavioral response. Meanwhile, if you try to express more strong intentions, perhaps you may walk one or two steps closer to the roadway. So it could be a bit threatening behavior, but that might be also quite strong intentions of the verbal nonverbal communication. So here we kind of simultaneously implement this real experiments. So in one way, the pedestrian, the other one who have the driving situation, and with this whole, one participants walk across the road, and the other one sit on the chair, and then with a this is actually the system we are using in a game, right? So it's a driving make a driving situation, and then how the simultaneous experiments shows these interactions between the pedestrian and drivers was the main concern. So we compare unsignalized the situation is unsignalized crosswalk, and we have multiple scenarios of the environment. Some scenario has this zebra crossing, and some of them does not. And also we have compared night and day, how it affects their perception and behavior. The participants was 108 university graduate and undergraduate students, and exactly half of them was assigned to driver, half of them was assigned to pedestrian. And we repeat this test multiple times. So each participant completing 10 trials. So just one trial is complete very, very quickly. So we gave specific guidelines for driving speed, and we gave the specific signs for the pedestrian. Okay, you are it's okay. You start to walk. You start to walk, or you start to cross. Of course, once we give the signal, pedestrian decide freely the point of the crossing. So to measure the next one is how to measure this nonverbal communication. So one of the way was that it's not working clearly. So this red dot is pedestrian, and this blue dot is vehicle. So it's approaching to the crosswalk, and this blue shaded area is the viewing angle of the pedestrian. So if the pedestrian gaze the front, this car may not located inside of this blue shade, but if they're turning their head toward the car for a specific time range, the car may be located inside of this blue shaded area. So we actually measured those time periods, how long time these vehicles are located within the viewing shade of the pedestrian. In 410 cases, at least 74% of pedestrians at least showed turning their head and looked the drivers during the crossing. And another one is because this VR system allows to measure the pedestrian behavior quite detailed, it can accurately measure how much they moved front or back. So they start from this point, and some of them definitely show that strong intentions to cross by approaching to this side, the 1 or 2 step forward. And in the proportion, about 33% of total case shows that the pedestrian are moving forward to show the strong signs of crossing. Okay, so for instance, if they close to in this case, the vehicle stopped before at this point, and then pedestrian move first, right? And in this specific these cases, the first one shows that the vehicle passed first, and the second one, the vehicle stopped before pedestrian move. So we collect all of these dynamic information and measure how much time period they actually located in this blue shaded area. And other details of the measurement listed here. I'm not going to explain all of them. But first, we investigate the level of risk perceptions, drivers, and pedestrian parts. For the driver's perspective, this head angle or the rotation of head angle or this gaze, direct gaze to the drivers does not affect their risk collision, but definitely this moving forward affect their risk perception. It definitely increase the risk level. And of course, we gave the two different scenarios of 30 kilometer per hour speed or 50 kilometer per hour speed. So when they drove a higher speed, they felt a higher risk. And day and nighttime, they felt higher risk perception. So it's not quite surprising. So of course, some of these results is quite natural. And for pedestrian side, their perceptions highly depends on either drivers yielding or not. So yielding means definitely they completely stop before they cross. In that case, they feel it's safer. And also with comparison with crosswalk, no crosswalk situation, this crosswalk mark definitely improve their safety perception. And this one is actual yielding model. Either the drivers yield or not in a specific situation. Presence of crosswalk is a strong kind of environments that increase the yields, and also the human moving forward. Or in here shows that when this mutual gaze time is longer, it is also highly affects the yielding rate of the drivers. So simple head turning toward the car is not it's not influential factors of yielding rate, but when we are allowed to quite specific eye focus, right? So which object they actually see. So we measure those gaze time, and when they mutually gaze each other, this one strongly affects the yielding rate. And we also found some of the intriguing aspects. First one is in this graph, this red line is smoothed speed of vehicle, and this blue line is the points pedestrian move, the first move. The most common situation is the A and B situation. So A situation is pedestrian just stand still and the vehicle pass first. The second one is the pedestrian also did not show the strong intention of the walking. The pedestrian and the drivers, the completely stop and then move the pedestrian. So which means, even without any kind of interactions in between pedestrian and drivers, the first decision, whether they yield or not, is completely depends on the driver's decision and driver's attitude. And another one, another interesting part was that the C and D, shows that pedestrian shows some movement, strong intentions of crossing before the car reach the crosswalk. But in case of the C, still the vehicle fast first. Meanwhile, in case of the D, the drivers quickly decelerate and then stop, and then pedestrian move first. The main difference between C and D is that the timing of the movement. So even the pedestrian shows strong signs of crossing, if the distance is too short, the drivers tend to increase their speed and quickly pass the point of conflict. Meanwhile, if they shows these intentions, like at least the 20 meters ahead, the vehicle each, and the vehicle tend to sharply decrease their speed and then read their intention and pedestrian move first. So this experiment shows that several interesting facts. So the first decision, who passed first, is primarily a driver's decision. Meanwhile, if pedestrian shows the strong sign of cross earlier, this timing is quite important. And also, merely turning the head does not affect the behavior of drivers, but stepping forwards or strong longer mutual gaze time between pedestrian and drivers was decisive factors for effective yielding. And I think in further extension, this mutual gaze, like eye contact in between pedestrian and drivers, may not working in an autonomous vehicle. And we already thought about how this kind of nonverbal communication between autonomous vehicle and a pedestrian can be expressed in the future. And I think this finding also has an implication about the study, implication on this case. Okay, so I explained two details about the first one. The second one was this is also multiple travel agents. In case of Korea, the e-scooter was first introduced in 2018, and at the early period, this regulation was not completely established. So some people use the e-scooter on the sidewalk, some of them use on the roadway. But after 2021, there are more strong, strict enforcements of sidewalk riding ban from the 2021. So now all of the e-scooter have to cannot be ridden on a sidewalk. It should be used the roadway. And after that kind of enforcement, the market of the e-scooter was completely collapsed because it's too dangerous to ride the e-scooter on the roadway. So I just have thought about is there any way to mix or kind of make some harmony of a bike pedestrian and e-scooter in the same space. So in this study, I actually kind of make a real environment with mixture of the three travel agents and how each other perceive each other and then how actually react about the threat of each other and also to think about there is a way to make us more harmonious in the situation of those three modes of transportation. So we actually make simultaneous kind of real experiments situation. Unlike the previous case, because we have the pedestrian have to stay with here, the pedestrian use keyboard to move. Meanwhile, the bike and e-scooter, we actually make that model and then make a sensors and then sensing those movement or field rotations based on that, we create this with a system. The participants were similar size, 102 and 102 adults, mostly graduate undergraduate students of the university. And we make three different environment scenario. And the first one is all of the three travel agents mixed together in a shared sidewalk. And this is also current situation. So in the bike lane. So if we have bike lane, the e-scooter can be ridden on the bike lane. So pedestrian use this side and e-scooter and bike use on this lane. And this one is kind of imaginary scenario. It's not actually working. It's not reflect the reality, but this imaginary scenario assume that each one has their own exclusive right of way. So in those situations, how these the travel agents interact and perceive each other was the main concern. This is one of the diagram how they move. Of course, this is quite exaggerated image of y-axis. But on this sidewalk, they start a pedestrian bike and PMV means the e-scooter. So the e-scooter, bicycle, pedestrian start at the same point, and as time goes by, they actually moving showed some swerving, some evasive actions within the sidewalk environment. We kind of measure these XY points, and with the temporal information, we measure the timed collision, which one indicates the risk of collision. So timed collision is, of course, this is kind of temporal changes, but the closest point, the minimum TTC is the closest point between each travel mode. So if the minimum timed collision is too small, which means it is very close or near collision situation, it is we can think that this is a risky environment, risky situation. Meanwhile, if the minimum TTC increase, there is enough space and time in between travel agent, it is safer environment. Descriptive analysis. Actually, the swerving, deceleration, and stop is a subcategory of evasive action. So when they kind of meet each other, they show some of evasive action. About evasive action and what types of evasive action actually occur in between different mode of travel. One of the kind of consistent patterns was that the faster travel agents are more likely to take a evasive action than slower agents. So when pedestrian bike or pedestrian PMB, the occurrence rates of evasive action of pedestrian bicycle PMV and the e-scooter is much higher than the pedestrian. And when you compare PMV and bicycle, we also found a similar pattern. And in terms of the risk assessment, this is a subjective risk assessment. Pedestrian risk or threats was not quite different. The PMV and pedestrian against the bicycle and e-scooter was not different. But in between bicycle e-scooter and e-scooter bicycle, they think the other kind of travel agents quite threatening agent because the speed is also quite fast. So so it's not quite a surprising finding. But what was not the one we haven't expected was that at least in the subjective risk assessment, pedestrians' perception about the bicycle and PMV was not quite different in terms of the threats. And we make a structural equation model to explain this kind of relationship. So these parts, these yellow box parts, is occurrence of evasive action. So this perception distance means actually the initial point of evasive actions. So if the distance is very close, they start these evasive actions quite late. Meanwhile, if the perception distance is quite long, they start to evasive action that will be either swerving, stop, or decelerations much earlier than starts quite early. So there are the three sidewalk type we defined first, and the directions between modes means with some scenario they move the same direction, and some of the scenario they move in opposite direction. Of course, the threat will be different. And this part is the collision risk. Right? So I just explained that minimum TTC increase as a safer situation, and minimum TTC decrease is a risky situation, and this is a subjective assessment of risk against different travel mode. So because this model has a pair, right? So pedestrian's view against bicycle, pedestrian view against e-scooter, and bicycle's perspective to pedestrian, and PMB's the e-scooter's perspective to the pedestrian. We make a model for this situation, and what we have found was it's not completely consistent. It has some variations, but there is relatively consistent patterns of those relationships. So the first one was the interesting part we found was that the sidewalk type was either they are mixed or separated, right? Completely line separated. And this complete line separation and exclusive lanes for each travel mode increase minimum times collision. So which means encourage the safer environment, because this exclusive lane kind of enforce some minimum space in between travel agents, this minimum time to collision tend to increase. But indirect, if we assume, if we account for this indirect effect, if we create the complete line separation, they tend to initiate evasive actions later than shared sidewalk situation. So so it is also kind of makes sense, right? So in a complete line separation, people think that this is safe environment, so they delay this evasive actions until when they come close. So that means, but this kind of late or delayed start of evasive action also decrease the minimum TTC, which means increase the risk of the collision. So in a direct effect, this line separation can improve the safety, but if you account for indirect effect, this line separation, the effect of line separation may not as strong as we first think. You know, some of those direct effects can be reduced by this indirect response of travel agents. So yeah, these are kind of so some of the facts we have identified from this real experiment. And the third one was, as I said, that how this presence of peers in a crossing situation affects pedestrians crossing decision making. So we first assume that the built environment may affect the cognitive patterns of the pedestrian, and this based on this cognition, so okay, this environment is safe and this environment is quite dangerous. That kind of based on that kind of cognition, they will show different behaviors in a collective crossing situation, and this collective crossing situation finally affect the crash risk. 10 minutes until finish, or
We'll leave some time for the Q&A.
okay, including the time of Q&A?
And then 10 more
Okay,
minutes.
okay, sure. So the number is always small, similar, like 102 participants. They are not same participant, but our target number is about 100. So 100 undergraduate students participate in this project, and in this case, the vehicle is just avatar system, so programs, and two crossing travel agents simultaneously cross the same crosswalk. The environment is about this scale, and the built environment situation, we gave some of the variations, but ultimately this environment does not affect behavior. But anyway, we give different types of crosswalk. Absence, existing, and raise the different color. We thought that this environment may affect the awareness of the pedestrian. And the types of interactions, this is control case, the participant who cross alone. And these cases cross together. It could be either leader or follower of the crossing. And these cases, the situation, the other agent gives some signs like warning or attracting people. So how this one affects the behavior of the crosser was the main question. This is a descriptive statistic. Compared to alone, the group crosser, the crossers with a partner shows that they're less likely to focus on the roadway approaching vehicle. We interpret that their awareness tend to be decreased, and also they tend to walk in a slightly different aspect. They tend to cross a slow speed, and also in terms of TTC, the time to collision, they are exposed to more dangerous situation than the situation walk alone. And in this group case, there is also two cases, first crosser and second crosser. When you compare the situation of these two, the second crosser tend to be more visually distracted by the first crosser, and they tend to wait longer. So we interpret that they kind of hesitate to decide the time gaps, take longer time. And also in terms of TTC, they're exposed to more dangerous situation compared to the first crosser. Based on this understanding, we make a mixed effect regression model, including all built environments, and and also the order of crossing, and also compare the walk alone and groups. The result was not quite different from descriptive statistic, because this built environment effect actually does not show a meaningful direct effect on the behavior. The more meaningful result is that those who walked with their partners are significantly dangerous situation than walk alone. They are more visually distracted by others, and shorter waiting time and slower crossing speed. We interpret that all these elements can be understood as a risky situation. And also compared to the first crosser and the second crosser exhibits higher crash risk. But unlike our expectation, built environments definitely affect their perception level of the crash, but it was not affect the actual behavioral patterns or the results of the TTC, the actual crash risk. So I probably couldn't explain the fully detail about this study. The second and third one is published in TLF and Accident Analysis and Prevention this year and last year. So if you're interested in about the results, you can find the papers and download the paper and read that. What we want to share with you is that these are just some of the examples we can conduct using the real technology. But there is some common challenges I experience. So one of the biggest challenge of this VR study for this pedestrian safety is that we can quite detailed measure the behavioral change, but there is quite limited theoretical framework to interpret those behavior. For instance, some literature explain slow crossing speed is because they walk slowly because they feel it's safe. But some study interpret the same behaviors completely different way. So they walk slowly because it's dangerous. So it could be either could be happen in the real world. So this when you try to refer some specific literature to interpret the specific reactions of the behavior, there is a quite limited literature that explain with a sound theoretical background. That is one of the difficulties of interpreting the sensing data. And also this pedestrian behavior study is quite complicated because the human behavior is always hard to explain, right? So unlike the vehicle, in case of vehicle, they have a specific roadway, and the way of the movement of vehicle is a letter has some specific type, right? So left turn, right turn, deceleration and acceleration. But the pedestrian behavior is much more complicated. They sometimes shows quite meaningless behavior on the sidewalk. And also, it explained that even though the pedestrian recognize something, this cognitive change do not always lead to the behavior change. So it is in many cases, it is hard to find out very constantly meaningful findings. We have to kind of have the filter these noises and try to find out the relevant actions on those kind of complicated shape. And as I shows examples here, all of the real study I conducted was done in a quite a small scale, like a 10 by 10, or in bigger ones, 20 by 20. But for the transport planner's perspective, we try to derive some meaningful findings, implications in a city-wise perspective. So how to link these kind of factual elements of real findings into the policy perspective, the bigger perspective is also quite challenging issue in the real study. But at the same time, this behavior is many things has been unexplored yet. So I said that there is a relatively limited references and it's hard to interpret, but in other ways of thinking, that means there's a lot of things we can develop theory by ourselves and test it. And also this kind of improvement of development of some biological indicators such as pupil diameter. So they actually measure change of size in the pupil in the eyes. And this one changed based on their stress level. And also this electronical, I don't know, brain signal, right? So we call this EEG or heart signal. There are many studies try to explain the relationship between psychology and biological indicator. If we can apply them, we can even develop more upscale methods. And also the real experiment is one of the rare, I think one of the rare opportunity to conduct quite controlled experimental research design. So in many cases, in urban studies or transportation studies, it is hard to make experimental design, right? Because in the real world, it's almost impossible. So from that sense, it has quite big strengths against other types of approach. So and also the VR technology. I studied this VR application of this VR about 5 years ago. But within those 5 years, I can see quite improvement in the sensing technology. So perhaps for the next 5 or 10 years, we can make a more refined or sophisticated experiment design with this technique. Okay, so this is the end of my seminar. And I don't know if it's slightly longer than I expect. But I'm happy to welcome question or comments for the study.
So do you regard the experiments you have done with the light speed and controls basically environments? Or,
It is control,
Yeah.
yes.
do you expect in uncontrolled environments like in the daily low space, the behavior would be different?
Uncontrolled. Could you give some specific example of
Like,
uncontrolled situation?
in a real world, crowded city center, which the behavior of pedestrian, for example, be different from your experiment.
Oh, sure.
I mean, it could be more like sensitive or more responsive to certain stimulus.
Well, this is not real study, but one of the study I conducted was using the video camera. Yeah, video camera, and record this video camera and using the sense segmentation and detect the movements of pedestrian and vehicles in a crosswalk situation. That is perhaps one of the example of uncontrolled situation. I do not have attempt to directly compare the same real and situation, but that is one of the way to conduct controls uncontrolled experiments. Is that
Yeah,
point?
that's fine.
Yeah.
So in the experiments where you've had multiple pedestrians, both of them were free agents, they could do what they wanted, choose to cross or not.
We gave them big guidelines. No, they are supposed to cross, but the timing of the crossing was determined by themselves.
So what I'm thinking is you could have had one of them be a free agent and the other one, you told them whether to wait or to cross and use that in a more structured way to see whether that would induce the second, who was the real subjects.
No, we do not give kind of.
I sort of understand you didn't. Have you thought about doing an experiment where you would give instructions so that you could see under what conditions you would induce somebody else to be a follower or a stayer?
In the previous situation, I don't know, that's exactly the point you want to ask, but we gave them two of them are supposed to cross, but who was first and the second was not given in the guidelines. So what is that point you want to?
Well, I guess the question would be, you could give guidance to one of them could be one of your agents rather than an actual subject. And then you can use that to test whether the subject was behaving in a more systematic way. Right? If you told one of the agents to pretend to be another subject, but they weren't really, they were really an investigator. And you told them to walk across, then the other agent might be more keen to follow based on the first agent. So you could test for follower behavior more clearly.
In the case, for instance, in the specific case, not all of them are pairs. Some of them it's not kind of instructor, but we use some cases avatar with avatar. And this comparison between first and second crosser is kind of mixed results with paired failed experiment and with avatar experiment. So some of I'm not sure what is the main concern about
Well, my
the
question would be that in your avatars, did you instruct your avatars to walk first? Did you instruct your avatars to walk second? Because you can turn a, if you have two free agents, then it's a fairly uncontrolled circumstance. There's nothing wrong with that, but it's an uncontrolled circumstance. And with a limited number of subjects, you only have 102 people. It might make sense to make it a more controlled experiment where you knew what one of the agents was going to do, and then you tried to elicit a behavior from the second subject.
okay.
It's experimental design, and you can't change it after this experiment, but if you do more experiments, it's something.
Okay, yes. Yes, if we can control the kind of, yes, the first and second cursor, perhaps yeah, the parts we haven't found can be yes, explained.
We have time for you. That's fine.
My question is for the first study. In Sydney, zebra crossings give right of way to the pedestrians.
Okay.
But in your study, it kind of felt like you said that usually the car decides who goes
Yeah,
first.
yeah, that's
And it was a bit like, that's weird, it should always be the pedestrian because it's a zebra crossing. Is that a difference in the road rules?
I don't know. I don't remember the exact number yielding late in Sydney. No, we have the kind of guidelines, right? If they conflict each other, the vehicles are supposed to stop. But in a transportation study, not just in Korea, but worldwide, the yielding rate was not quite high. So in our case, the yielding rate was about 30%. And these numbers was comparable to other cities in the world. So this kind of confliction is a quite vague, but this confliction between vehicles and pedestrian occur anytime, and say but it's hard to define a specific yielding situation, but in many cases, the drivers move first than the pedestrian in many cases. That's what I understand. Is it, do you have any idea about the Sydney case?
Well, I mean, Sydney, my experience is that the yielding went very, very high if the pedestrian is standing at the curb. But there's ambiguity if the pedestrian
It
is
is.
a meter away from the curb as to whether the cars will stop. So I think some of that is positional and the cars trying to figure out the intent. But if the pedestrian is clearly at the curb facing towards the crosswalk, I haven't gotten hit once. And I mean, that's gonna be a more than 99% yield rate.
Okay. So yeah. So again, if we kind of understand this yielding situation, like a more broader situation, the yielding rate, there is still the competition between vehicle and pedestrian. That's what I'm thinking.
Okay, thank you very much. Gi-Hyoug.